All right, the next section on our review, starting with number 5, we have this symbol, which means congruent, which means exactly the same size. So this is saying that triangle MNP is exactly the same size as TUS. So that means everything that corresponds is going to be the same size. So in this picture, we're missing information for X and Y. We want to see if we can solve for the piece that has the letter that's by itself first, because we don't know both X and Y. So I'm going to tackle this part that just has an X in it first. This piece, 2x minus 50, is pointing at U. So I can see U's in the middle up here. So that means it matches to N in the other picture. I don't have anything for N, but I do have these two angles. I know that every triangle makes 180 degrees. So what I'm going to do is I'm going to take 180 and I'm going to subtract 24 and I'm going to subtract 142. And that tells me my missing angle is 14. So I know that this angle is also 14. So we're going to say 2x minus 50 is 14. And then we're going to have to use our steps to solve this. We're going to add 50 to both sides. So 2x is equal to 64. And then divide both sides by 2. So I've got my value for x. Right, next I need to figure out my value for y. So y is in this expression. This side NP matches up with US. So I know that 2x minus y is equal to 13. I just figured out x, so I'm going to plug that in. So 2 times 32 is 64. And now I need to solve for y. So I'm going to subtract the 64 from both sides. And I get negative y is equal to negative 51. And then I would just divide both sides by negative 1. So now I've got x and y. Right, number 6, it says A, B, C, and D, E, F. We have these values. Can you prove that these triangles are the same, are congruent? Why or why not? So we don't have a picture, so it would be really helpful to have a picture for this. So I'm just going to sketch a picture of what this might look like. Okay, and it doesn't really matter what you make the triangles look like. You just need two triangles and label them. So A, B, C, and you want to label them in the order that you're given, right? A, B, C matches to D, E, F. A is 68. C matches to F, and they're both 59. And E is 53. So we know that B would be 53, and we know that D would be 68. A, B, this side, and D, E are both 8. Can you prove A, B, C is congruent to D, E, F, Y, or why not? So there are some congruent methods that we learned. These were our 4 congruency methods. So do we have enough information on our triangles? Well, we've got all 3 angles and all 3 angles, but none of these say all 3 angles. We have this side. So this side falls between these 2 angles. So angle, side, angle, angle, side, angle. So we can use angle, side, angle, or we could use angle, angle, side, because we could say C and B and 8. Or this and this and this. So either of those methods would work. So it doesn't matter which one we pick. We could either say yes by either angle, side, angle, or yes by angle, angle, side. Both would work. Okay, it says given DE is congruent to MN, so we're going to mark our triangles. And angle M is congruent to angle D. So we're going to mark our angles. What additional congruence is needed to prove that DEF is congruent to MNO by SAS? So this means I need a side, an angle, and a side. The angle has to be between the two sides. So right now I've got these sides, so these are my S's. I've got these angles. So if I want that angle to go between two sides, I would need this side to be the same. So DF would need to be the same as MO. That would prove by SAS. All right, number 8. It says, does the figure have reflection symmetry? If so, how many lines of symmetry does it have? So reflection symmetry means that I can cut it in half by like drawing a line through it. And if I fold it on that line, it would look exactly the same. So like in this star, I could draw a line down here. If I fold it on that line, it would be exactly the same on both sides. Okay, I can do that there. I can do it through every, oops, that was not a very straight line. I could do that through every vertex of the star. So in the star, we've got 5 vertices. So it's 5 lines of symmetry. So yes, and there's 5. All right, I'm going to stop the video here and start another one for the back.